Hi. Last time I was in a gathering with some friends when one of them started making that sound while sliding his finger along the rim of the glass. I was like, how did that happen? And so much curious to know the physics behind this phenomenon. So I came to my cousin, who plays the violin very well, to get some help as he studied musical theory and that musical note thing. There's something super interesting in here. So tell me about how you generate sound out of glass.
Okay, simply by hitting the first glass, we get the frequency, and hitting this one, we get a different frequency. That because these glasses of water have different levels of water in them.
So as you decrease the level of water, the frequency
should increase.
Okay.
Yes. So it's inversely proportional to the frequency.
Okay.
Now let's start by defining what a sound is. A sound is a mechanical wave which is an oscillation of a pressure or a vibration that causes disturbance to travel through a medium, transporting energy without transporting matter. This sound is composed of frequencies within the range of hearing. Now these oscillations or waves are identified through some parameters such as period, frequency, amplitude, speed, wavelength. Here is a wave on a graph of time versus amplitude. The amplitude is the distance from the peak, crest or trough to the axis. The wavelength is the distance between two identical adjacent points in a wave. It's typically measured between two easily identifiable points, such as two adjacent crests or two adjacent troughs in a waveform. Period is the time that takes a wave to complete one cycle. For example, if a wave requires 2 seconds to complete a cycle, then the period of this wave is 2 seconds. Frequency is the number of waves that passed in a certain amount of time, mainly 1 second. Now, as number of oscillations increase or decrease, frequency varies. For example, short wavelength allows higher number of oscillations in 1 second, which means higher frequency, as presented in this equation, where wavelength and frequency are inversely proportional. So as the frequency is decreased, wavelength is increased and vice versa. Now, higher number of oscillations in 1 second or higher frequency leads to higher energy, where energy and frequency are directly proportional. On the other hand, long wavelength means lower frequency, which leads also to lower energy. For this reason, gamma rays have high energy because of their small wavelength. Amplitude of the wave determines the loudness of the sound. However, the frequency determines the pitch of the wave.
Can I make a musical instrument out of these glasses?
Yes, sure. So you think of it logically, like if you hit this one and this one. Okay, so there is enough difference to fit some musical notes between these two notes. Okay, so and if we had more glasses, we could make even more musical notes. Okay, I have previously tuned these glasses. You can use a tuner application on your phone, but it's a little bit hard to work. So because I play music, I also depend on my ears to form these notes. I made like this one is C, this one is D, E, F, G, and A, or you can name them like Do, Re, Mi, Fa, Sol, La, and it's not as the same tune as all instruments refer to. Okay, so it's only by hearing. Okay, so with respect to each other, the notes are right almost, but with respect to a musician playing, maybe it's different. Okay, for example, we can play this song. Okay.
As you noticed, the sound produced from the glass changes for different water levels, where as you add water, the mass increase. This increase in mass causes the glass to vibrate in larger and further apart waves. The larger and further the waves are, the lower of the pitch sound that the glass produces.
But there's a missing note.
So we conclude a glass of low level of water has a frequency higher than that with higher level of water.
So what about the sound you get when you slide your finger along the rim of the glass?
First, you should wet your fingers, okay? Then slide them along the rim of the glass. Okay?
Okay. This is called the step and stick motion also.
Yes, that's it. And it works mostly in wine glasses because of their hollow shape and thin glass.
Okay.
Okay? Then the same process happens while playing the violin. For example, playing on the first string, the bow, we first stick it on the string, then slide it.
Okay, so this is stick and slip motion.
Yes. The friction causes the string to vibrate.
So the vibration produced by your finger travels around the glass in a repeated pattern over and over again. And once these vibrations reach the natural frequency of the glass, it causes it to amplify. These vibrations travel from the air around the glass to your ears, and its heard is sound. This process is known as acoustic resonance. Now, changing the speed or pressure of your finger can make the sound louder or softer, but it doesn't change the vibration frequency. Vibration frequency is always determined by the shape, size, and structure of the glass.
And that was our video. Thanks for watching. Thank you, Raydan.
You're welcome. Please like, share, and subscribe for Rima. Okay, bravo.
ريما عم صور فيديو يلا يلا عيري يلا
لك شو جدي؟ هيك
Okay. Okay. May I try something that is I want to try something the other day.
يلا
And that was our video. Thanks for watching. Thank you, Raydan.
You're welcome. So please like, share, and subscribe for Rima.